Okay, this is our second video on tree diagrams, and we're going to extend on what we saw in the first video, and we've got an example here that will allow us to do that. And it says two people are selected at random without replacement from a group of three. So two people are selected and we have three choices. So we need to be clear on that. So if two people are selected, that means we will need to do a tree diagram with two stages. So two sets of branches. Now remember, we looked at these vertically. So in green you'll see that I've got stage 1 in line there and stage 2 going down that way. Okay, so you see two vertical dotted lines. Alright, and we can do part A. List all the possible outcomes using a tree diagram. So you can see I've got the branches started there and we need to put the information on. Okay, so I'll grab my pen and we'll put the information on. So it's a without replacement situation. We need to be very clear on that. So without replacement affects the way the tree diagram comes out quite a lot. So on the first selection we've got three choices: Annabelle, Brody or Chris. Okay, looking at the first branch here of Annabelle A, given that we've chosen Annabelle on the first one, it would mean that we could choose only Brody or Chris on the second, because this one is without replacement. On the middle branch, given that we've chosen Brody on the first one, we could only choose Annabelle or Chris on the second. Or if we chose Chris on the first, down the bottom here, we could choose Annabelle or Brody on the second choice. So that's the structure of our tree diagram, except for one last thing: we've got to put on the outcomes. So this will be the sample space, all the possible outcomes. First one's called AB, second one's called AC, BA, BC, CA, CB, and there should be 6, sorry. It would be 8 if there was with replacement. Sorry, there should be 6 in this case. So that's part A done. Part B, find the probability that the selection will contain. So we're looking for probabilities. Okay, B, part 1. Find the probability that the selection will contain Annabelle and Brody. So it's got to have both in it. So let's have a look at our tree diagram and look at the outcomes: Annabelle and Brody. So we're looking for A and B, not A or B, A and B. So it's got to have both in there. That's got A and B, and that's got A and B. The order's not important. It doesn't say anything about the order, just got to contain them. None of the others do. So we've chosen two outcomes, two favourable outcomes. So the probability of A and B, oops, I forgot to write in my B, close the brackets a bit too quick, is 2 over the number of outcomes possible: 1, 2, 3, 4, 5, 6, 2 out of 6, which is simplified down to 1/3. Okay, second one, the probability that the selection will contain Chris. That's all it stipulates. It doesn't say whether Chris is first or second, it's just got to contain Chris. So in green we'll have a look at those. AB, does it have Chris? No. AC, yes it has Chris, C for Chris. BA, no. BC has a C for Chris, CA has a C for Chris, and CB. So there's 4 favourable outcomes out of a total of 6 possible outcomes. That's 4 of 6, or simplified, that's 2/3. Last one, we've got Chris or Brody. Now there's a difference between and or. So and we saw back in part 1, it has to be both. Doesn't matter about the order, but it has to be both, regardless of the order. This is or. not and. So it doesn't matter which one as long as it contains one of them, but it can be both as well. Alright, so let's have a look here. I'll get a different coloured pen. We're going to go for this blue turquoise colour. So it's got to be C or B, as long as it's got a C or a B in it. So that's got a C or a B. Doesn't matter if it's got something else in it, as long as it's got a C or a B. So it's 1. That's got a C or a B. That's got a C. That's got a C or a B. That's got a C or a B. That's got a C or a B. And that they all do. Oh, well, that means it's a certainty. So probability of C or B is 6 out of 6, which is 1, and that's a certainty. So if you choose under those conditions, you will get something with either Chris or Brady or both. So let's commence work now on our tree diagrams part 2.